Hello everyone, welcome back to our channel. Now in this video we are going to start with a new data structure, that is trie. So trie is actually very special data structure, and just to be very clear, tries are not binary trees, and the reason behind that is they can have more than two children. Okay, tries can have three, four, five, six, maybe even more than that. Okay, so name of the trie comes from the word called retrieval, because most of the time we do that only with trie. Okay, tries are also known as digital trees, radix trees, and prefix trees. If you heard any of them, they are in the end tries only. And best use of tries is autocomplete. Okay, now this autocomplete is the same feature that you have on Google search engine. Okay, Google gives you suggestion in front of you based on the string or substring that you have entered, right? So that's called autocomplete feature. So this try is actually one of the best data structures to implement that. Okay, and the operations of lookup, insert, and delete all happens in O of L time, where L is basically the length of the word. The bigger the length is, the more the time it is going to take. So there are multiple implementation to implement the try. Okay, and we are going to look into few of them. First, let's implement this using array first, as I have written here. So to implement try using array, right, we need something called as a try node, and we'll implement then insert operation. So let's implement that try node first, which is actually a class. So private class try node. Now what it is going to take? It is going to have the value, which is actually a character. Now what else it is going to have? It is going to have a try node array. Now why this array? I'll explain that. Array is actually what's going to tell for each of the character what is the possibility of having the next character or the next word. And this array is going to have a fixed size, and I'm going to tell you the reason for that as well. This is going to have a size of 26, because in English we know there are 26 alphabets, right? And no matter which word you're trying to create, right, every single word, will be consist of these 26 letters only. That's why we are creating every single nodes having 26 children. Okay, so that we can form a complete word in those particular nodes only. So currently we have this 26 only there. So someone else who is trying to read your code, right, they might not be able to interpret this number properly, because this is a code smell also, and the name of this code smell is magic number. We don't know there is a number. What is the significance of having this number? So to remove that ambiguity, we can replace this 26 with this English alphabet variable. Now we need one more, that is a Boolean value. Okay, now why we need this? End is end of the world. So we need this variable because for each of the node we are going to insert the value, but that particular node might not be the end of the word. So wherever we have this is end of the word as true, right, we will know that this is a end of the one single word. So we know that word exists for sure in the try. We are going to implement, and I'm going to show you that as well. Okay, so is end of the word. Now what do we need? Let's have a constructor which is going to have our value. Now let's have our toString method which is going to have a character. Let's remove all this. We only need value. Perfect. So now as you can see, we have our try node ready. Okay, we have all the required values. Now we need one root node. Let's create that root node as well. We have our root node as a white space character, because first character we don't want to hold any of the letter. That's a single node. As a children we have the 26 children, and from there onwards we are going to start forming the letter, forming the word basically. So we have our root node ready. Now let's implement our insert method. public void insert. Now what do we need to insert? A word. So now let's start implementing our insert method. Let's have our try node in our current variable so that we can go ahead and easily iterate through it. Now let's create a loop while for each of the character in world dot to char array. Let's get the char index first. And how do you get the correct character index? So from each of the character you're supposed to subtract a so that you will have the correct index for that particular character. Now you need to check if in root dot children for that particular character index if that particular children is null, then you're supposed to create that particular node char index is equal to new try node with that particular character. So now we need to continue the iteration as well. Okay, for insertion of other letters. So for that we need to do current is equal to current dot children of that particular character index. Once it moves there, it can continue adding all those characters in the world, and once it is done adding all the characters right in our try, in the end what we are supposed to do, whatever the root node that we have right now, which is in our current. So once you're done inserting that particular word in our try, we are supposed to mark current dot is and end of the word is equal to true. Now why we are doing this? Because once we are done inserting the string, we want to tell ki this is the particular place where you are actually completing one word. That means this from root till this point, that is a single word. Okay, so this we are doing after inserting every single string, and we are done with the implementation. So let's demo our method try is equal to new try. This is our own implementation of try dot insert cat try dot insert cap try dot insert can. So I have inserted three different strings in which initial two characters are same but the third letter is different. So now let's look at our try and see if we are able to insert it properly or not. Then now let's look at our try. We got this error because actually we wanted to iterate using this variable current, but we iterated using root. So let's change that to current and this as well to current. Now let's run it again. Now we are supposed to get it right and we are getting it correct. Now we are able to run the program, but we also have to check if those three words got inserted in our try or not. So as we can see, first root is empty, which is root node. That's what we have right here. Okay, now from next node onwards we are supposed to check our values, the word that we have inserted. Yes, first letter is C, which is correct. Now second, it has one children at 0th index, which is A. Now this is supposed to have three children and it has three children, which is N, P and T, can, cap and cat. So our implementation is perfectly fine, and you can also see one more thing, that for these three, right, is end of the word will be true only, you see. But if we look at this A, where is this? This is A, right? Is at the end of the word is false. So that's what I was trying to show you, that once the word is completed, right, then only it is marking that particular node as true. So what we have done here, this is a array implementation of trie. We have created our trie node class, okay, which has value. Children nodes is end of the word variable. We have created our root node. We have created our insert method where we have our temporary current node, and for each of the character we are iterating through the array. We have taken the character index, we have subtracted it with a because we wanted to find the correct index. Then if the value was not there, we added that particular value in the trie node and we iterated till we were able to insert the complete word, and then we marked the word as true, and that's it. Once we iterated, we were able to iterate through the word properly, and that is the trie implementation using the array. So that's all I wanted to show you as part of this video. See you in the next one.